Hey, good afternoon, everyone. Today we're going to cover inference about two population means. This is from section 11.2. This is with what's called a matched pairs design. So every problem here is going to involve matched pairs with two different means. They're not going to be independent samples. So I want to be clear. You go, what do you mean by matched pairs? It could be like the same person doing something on one day and then doing it again on another day. All right, so that could be a matched pairs. It could be husband and wife. It could be twins. It could be we'll do a problem today where we go to a certain location. We might measure something. We'll come back a month later or a year later, go to that same location, same geographical location and measure something. That's matched pairs. All right, totally different than if we just randomly got a bunch of women and a bunch of men and just stuck them in two different groups, like a control group and a treatment group or something like that, where they're independent samples. This is what we match pairs. So it's really, we call it dependent. We call them dependent samples. But it's matched pairs, and you can think how they're paired up. Everything be paired up, but sometimes it's the same person or the same thing done twice. That happens a lot of times. I'll start the first problem like that. So the first problem I'm going to do, when it deals with, we're going to look at two different population means. I want to get something maybe everyone in this room could relate to. And the problem, it's in the textbook, it's number 17, and it's dealing with the octane fuel. So when you go to the gas station, what do you fill up with? You get the 87 octane, cheap stuff. You get the high test stuff. You may get the high test stuff, the 92 octane. There's quite a difference in the amount of money. Who goes high? Yeah, me too. Who goes low? A bunch of people, and that's, so, and it's the idea of like, what does it do? You're spending so much more money, and you go, well, I've heard this. Well, I've heard you get better gas mileage. I've heard it gives you a longer length for your vehicle and stuff like that. I think I do it because my dad did it. It's like my dad always made sure if I had to go to the gas station and fill up his gas, he's like, make sure you get the high test. I'm like, I will. So I just continue at this day. But it's a lot more money, so you spend a lot more money every time, so it's just something to consider. So someone wanted to look at that. The whole problem is, is using a higher octane, like a 92 octane versus the 87 octane, giving you better gas mileage, right? Are you going further with your car with the 92 octane? So that's what we're going to look at. And it was a neat example in this problem. He just went out, randomly chose, I think they got 11 people, all right? And that person had to bring their car, so everyone got their car, right? They drove on the same course, so that's important. They made sure to do the same course. That course, everyone reflected like city highway. They made a little course. They got 10 gallons of gasoline, all right? And they just drove the car until they ran out. And they're going to get two runs. One of the times they're going to run their car with the 92 octane, and then the other time they're going to run it with the what? 87 octane. Now, which one did they do first? Just to keep it as random as possible, they flipped a coin. They flipped a coin to determine are they going to use the 92 octane first in their car or the 87 octane first. And they didn't tell the driver. So the driver, it's blind, like double blind experiment. Well, in this case, the driver's blinded, meaning not whether they're driving blinded, but they didn't know. That'd be bad. That'd be bad. They didn't know whether they had the high test 92 octane or the 87 octane. And they just drove the car until it ran out of gas. Okay, and we're going to look at how far the cars went, and we're going to match them up. So this is a matched pairs design. And we'll do a little experiment. We're going to see, hey, is there evidence to conclude that perhaps the higher octane gas gives you what? The better, gives you more gas mileage. Cool? So this is on page 552. It's an 11.2. And it's number 17. All right, let's look at this. So I'm going to list the 92 octane first. There were 11 drivers. All right, so there's 11 drivers. So I'll just put here driver number. And I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right. And then 92 octane. And then the 87 octane. So for driver 1, 237, 238, 229, 224, 119, 297, 351, 241, 186, 209, and then the 11th driver, 562 miles on the 92 octane. Oh, what do you call these columns here? And we'll get started on once I just put down all these 87 octanes. All right. That's how far the cars went. They're in miles. I was on 10 gallons of gasoline, so you can see who's driving some big truck and who's got some kind of hybrid, lightweight car, getting a lot of miles out of that 10 gallons. All right. How about the 87 octane? 234. 257. 243. 215. 114. 287. 315. 229. 192. 204. And 547. All right. There we go. Obviously, this is a matched pairs design. All right, this is all we got. Who's got the heavy truck? Right there, huh? What's that? A little bit over 10 miles per gallon there? Car there. All right. Well, what are we going to do with this problem? We are going to perform a hypothesis test. All right, this hypothesis test will be about these two population means. What are we going to look at? The difference of the two population means. And it's a matched pairs design, right? Well, you go, well, what will our null hypothesis be? We're going to look at the differences. So after you have all this copied, I think right here, I'm just going to put the word difference. Yep, that's what we do in a matched pairs design. We're going to find the difference. What's that? We just subtract each one of the pairs. They're paired up. It's the same driver, right? Yeah, it's the same driver doing it 2 times. And some of your question, hey, you only got 11 people in your sample. Do you remember what the sample size was supposed to be higher than for means? 30. So we'll talk about that. A lot of you probably are curious about that. You're like, you got a small sample size there, Professor. Hey, what's going on? So we'll talk about that. We're going to have to make sure we're allowed to do the test. We're going to have to make sure we'll go to the checks to see, well, what do we got to do when your sample size is less than 30? Is there anything we got to look at? And we do. That won't be too bad. But I do want to point out, let's focus on the most important stuff right now. We're going to look at all the differences. We're going to subtract all these, and that's what we're going to look at. So I'm going to put a star right here. So yeah, everyone in the matched pairs design, it's really all about this stuff. These are the numbers that are going to be important to us in a matched pairs design, or the dependent samples. Next class, next lesson, we'll do independent samples, okay? Not today. All right. Now, is everyone okay for this problem? You could subtract either way. I think it'd be great if we all as a class just subtract. How about 92 octane minus 87 octane? So I'll put that in parentheses. When I mean difference, how about 92 octane minus, I'll put the word minus 87 octane. How about that? 92 octane minus the 87 octane. We'll take this one, we'll subtract this. Cool? Now you can do it with your calculator. Right? You could probably just subtract quickly. All right, some of these numbers might bug you, like what's 119 minus 114?
5.
5, right? We're just good at this stuff. And we'll subtract them. And some of you doing it right now, but when I was going to use the calculator to do all the subtraction for me. So if you want to do all the subtractions right now, I'm sure you can mentally, you're pretty good. You know, but 241 minus 229, you might be like, is that 11, 12? I'm going to let the tool do it, so I'm not even going to write those down yet, okay? But what we're going to do as you're getting everything copied is we're going to do a few things. First of all, we're going to set up a hypothesis test. Then we're going to verify our requirements. And you go, what are we going to look at? The sample size is great, just 11. We'll talk about that. We'll perform the test. That means we'll do classical approach. We'll do the p-value approach. And then we're going to state the conclusion. There is evidence, or there is not evidence. And we'll do that for each problem of that. Sound good? I think we do 3 of these. These are fun. I love this chapter when everything we did all year. All that stuff where we just find the probability of this, probability of that. Now we get to put it into play. We look at stuff that's meaningful to us, and we can see like what's the chance this could happen, and we use the probability to indicate whether or not we have evidence or not. Kind of neat. Neat problem like this. So what's my null hypothesis?
HO.
HO. Watch what I write. And when this is about this guy, isn't it a mean? Well, watch what I'm going to write here. I'm just going to put a U. Excuse me, mu. It looks like a U. Mu. I'm just going to put a subscript of D. That subscript of D stands for difference. And my null hypothesis doesn't make sense to you. It's just that the mean difference is 0. There's no difference. No difference. No difference in the population means. That's what you always do in 11.2 for matched pairs. Every time you do a matched pairs design, that's your null. Mean difference 0. No difference in the population means. But H1 is, it could be one of 3 things. It could be a less than 0. It could be a not equal to 0 or a greater than 0. We've got to determine this. Well, everyone, if we're doing 92 octane minus 87 octane, remember alternative hypothesis was this? You know, the alternative hypothesis is that the 92 octane gives you better gas mileage. So we're saying higher amount of mileage minus lower amount of mileage, wouldn't that be greater than 0? So I'm going to put greater than 0. I want to be clear about that again too. So people are like, wait, why'd you make it greater than? It was about this whole problem in our hands that we have here. You know, the alternative hypothesis was this. We're looking at whether or not this 92 octane gives you further mileage in the vehicle, right? For the same amount of gallons, better gas mileage. So this would be, we're saying that this minus this being smaller would always be a greater number, right? So this difference would always be greater than 0. Does that make sense? You know, like, I want 100 miles versus 80 miles. Well, that's positive, right? We're thinking, yep, this should give it, make the car go further. This won't go as far. It's always going to be higher than 0. So that's how we're going to set it up. Now we got to verify. So we're going to use the calculator for this. And we're going to verify our requirements. Some statisticians say, check the conditions. I know, it's the boring part. It's the boring part. Yeah. Now, if this sample size was greater than 30, we'd be ready to roll, wouldn't we? But I'm sure when this might have cost a little bit of money to get all these people on the tracks, and people are taking their cars and they're driving and they're running out of gas and stuff. They got 11 drivers. So what we're going to do is we're going to go to calculator and we're going to determine whether or not we're going to look at the box plot and just make sure there's no outliers and see if it's roughly approximately normal. Remember, a box plot's approximately normal. Some box plot might look like this. Put that in the center. See if it's approximately normal. All right. We also should do, I'll tell you what we should do a normal probability plot, but we don't have Minitab software, okay? But I do want to point out, with Minitab software, the differences did show that it was approximately normal. So I'll mention that again, so if anybody's curious about that. So let's go to our calculators, let's get this stuff in there. How about this? You want to put this in L1? We'll put that in L2. And then we'll just tell the calculator, take L1, subtract L2, and store it in L3. Will that work? I'll walk you through it. It's only take like a minute or two. We'll put all this, we'll enter in the data to take the longest. Put that in L1, put that in L2. Then we'll inform the calculator, hey, in L3, would you store L1 minus L2? Sound good? All right, let's do it. I'll also talk about the final exam, and you're like, boy, this could take me a while to type all this stuff in. You know, how a lot of times you can design on the final. You know, just to facilitate all that typing in. Final exam is always good to make it so you have to enter so much data. All right, let's go in here. Stat edit. Everyone, I'm just going to clear this thing out. $234. Clear. Over here. Clear. Clear. All right, let me start typing L1. I cleared out my list, right? To clear out a list, you just up arrow there, you hit clear and you hit enter. Never hit delete, right? You'll delete your list. All right, I had numbers in there, I'm just gonna enter all these. 237, 238, 229, 224, 119, enter, 297, enter. So I'm at 6, right? 351, 241, 186, 209, and a 562. All right. What about the 87 octanes? 234, 257. And when it's very important, I enter these in order. Do you agree?
Mhm.
This is very important.